All right, so this week, we're going to start this section. Other types of equations. We've done linear equations, and last week was quadratic. Okay, so this week we're going to do polynomial equations. We're going to do rational equations. We're going to do radical equations. Thursday, I'm going to have ACT bonus day for you. We'll do a little, I'll give you an old ACT test and give you like 30 minutes to work on it. And for every 4 you get right, I'll give you a summative bonus point. And we'll put that on this 9 weeks. We're off Friday and Monday. And then Tuesday next week, we'll do the fourth type, these equations, different types of equations, which is rational exponential equations. We got rational exponents, meaning fractions for exponents. And then we'll go ahead and have our practice quiz next Wednesday and go over it next Thursday. Then we'll have our first quiz of the second 9 weeks next Friday. Okay, so that's kind of what we're doing this week and next. All right, so get a bonus opportunity on Thursday, which will go on this 9 weeks. That'll be your last grade of this 9 weeks. Okay, so the types of equations we're doing today are polynomial equations. So we usually solve these by factoring. Okay, so when you have this type of problem, you try to factor it. And is there a GCF for this problem? No. Is it a difference of squares? Yeah, it is. So, Brendan, how do I graph this difference of squares? Factor this difference of squares, not graph.
X plus or minus 4.
All right, plus or minus 4. That's correct. But what's in front? Is it just x or? Well, it's x to the 4th to start. So what are we going to do for these? Yeah, x squared. We're going to take the square root of x to the 4th, which is x squared. But one's plus and minus, like Brendan said. Now, can I factor that any further? Not this one, but we can this one because it's minus, right? This one we can, it's plus, but we can solve it. I'll show you in a minute how we can finish that one. But this one we can factor a little further. So I'm going to leave this one the same because they're both perfect squares, but it's addition. In order to factor them, when they're both perfect squares, it's got to be subtraction, like this one on the right. What's the square root of x squared? And the square root of 4, and then plus and minus, right? So we factored it now. And once we have it factored, we set each factor equal to 0. So we're just going to write x squared plus 4 equals 0, x plus 2 equals 0, and x minus 2 equals 0. On these, we're just going to add 2 and get x is 2. That's one answer. This one, we're going to subtract 2. We get negative 2 is one answer. And this one, we had, like last week, we're going to get the squared part alone by subtracting the 4. And then what did we do last week when we had this situation? Square root both sides, right? So when I square root both sides, I get x equals, and you guys did not forget the plus or minus, right? On your quiz. I don't know yet because I haven't graded them. But hopefully you didn't. And what is the square root of negative 4? 2i, right? I because it's negative, and 2 because 4 is a perfect square. So here's your 4 answers. Positive 2i, negative 2i, negative 2, and positive 2. And whatever this exponent is up here is how many answers it should have. You know, we did quadratics last week. They were always x squared, right? It's always 2 answers. All right, well, this one has 4 answers. We did all that by factoring. okay? Any questions on that example? All right. So we just factored as far as we can, and then we figure out our answers. Now this one, we're going to try to factor. It's got 4 terms. So what do we usually do? We have 4 terms we want to factor. Yeah, we group them, right? So we're going to group first 2 and last 2. And since this has a minus in front, I'm going to put it in my group. Just put a plus sign between them. And then we look for GCFs, remember? So what's the GCF in this first group? X squared. Whenever this second group, we're looking at it, and the third, this first term in the second group's got a negative in front, we pull the negative out. What else goes into 2x and 8? 2, right? So we'll pull negative 2 out there. X cubed divided by x squared is x, and negative 4x squared divided by x squared is negative 4. And negative 2x divided by negative 2 is x, and 8 divided by negative 2 is negative 4. Is it working out the way we want? Yeah, that red part, the x minus 4s are the same. That's one of my factors. And then my other factor is x squared minus 2. And then again, we just set them equal to 0 and finish them up. So I write x minus 4 is 0, and x squared minus 2 is 0.
Is x squared minus 2 not
Difference of squares?
Yeah.
No, because 2 is not a perfect square. But that's a good one. X squared is a square. You got the minus sign, but the 2 isn't, so I can't go further. But that's good that we're looking at that and seeing if it was one of those difference of squares. So here, I just add 4, and I get x is 4. All right, here, I want to add 2. And get x squared is 2. So what do I got to do since it's x squared? I got to square root, right? Like we did last week. All right, so I get x plus or minus. Can I simplify that 2? No, so just leave it radical 2. So I got 3 answers: positive radical 2, negative radical 2, and positive 4. What's this original exponent in front? Cubed. So how many answers should I expect? 3. That's what we got. We got 3 answers in it. Okay. Remember, this plus and minus is 2 different answers, right? So if you wrote them out, that'd be our 3 answers. Okay. Questions? So today is factoring. Okay. Solving these polynomial equations by factoring. All right, so what should I do first, Lily? Yeah, take out x squared. Yeah, I don't know. When I typed it and I put it in here, it just went really big, but it's all right, right? So like Lily said, we're going to take that x squared out because that's the GCF. And then x to the 4th divided by x squared is x squared. I'm going to turn that off, though. And then negative 36x squared divided by x squared is negative 36, right? What's that thing called? Yeah, those are difference of squares, right? So I can go another step. So the x squared doesn't change, but the x squared minus 36 is one of those difference of squares. So I take the square root of x squared for the front. Square root of 36 is 6 for the back. And then 1's addition, 1's subtraction, right? So then I set them equal to 0. So x squared equals 0. X plus 6 equals 0. and x minus 6 equals 0. And then I'm going to add 6 here. And get x is 6. Here I'm going to subtract 6. And get x is negative 6. Then here I'm going to square root, because it's an x squared. So x equals plus or minus. What's square root of 0? Just 0, right? So positive or negative 0, you can't really say. It's just 0, right? But that is what we talked about there, since, we're thinking there should be 4 answers, because it started out x to the 4th, right? We got 2, this, 0 is plus or minus 0 is still 0. But we can treat it as, 2 separate answers, or we can say 0 works twice. It has a multiplicity of 2. And we'll talk about that later on this year. We talked about it last year. But if we were looking at the graph, whenever a number has a even multiplicity, it works twice or works 4 times or 6 times. If we're looking at the graph will hit the x-axis at that number and bounce off. Either come down and hit the 0 and go right back up, or it'll be coming up from the bottom and hit 0 and go right back down. Okay, it bounces. All right, and we'll talk about that stuff, not this week, but later on this year, we'll talk about that kind of thing. What the graph does when it hits those zeros. Sometimes it'll go straight through the x-axis at that number, and sometimes it'll bounce off. Sometimes it'll bend as it crosses the x-axis, right? So the last example for today is one of these. What do we call this type when we want to factor it? When we were doing factoring, we had a list. We wrote down all the steps for factoring, a way to think through it. Number 1 was a GCF. Always do that first when you're factoring. Number 2 was look for a difference of squares, which meant it had 2 terms, and they were both perfect squares, and it had a minus between them, like this x squared minus 36. That's what's one of our difference of squares. Number 3 was called a sum or difference of cubes, and that's what this is. Okay? So when you do it, 27 is a perfect cube, right? How do we check? Remember, where's the cube root button on our calculator?
Math.
Yeah, it's in math. Good. All right, if we hit math, number 4 there, that's cube root. So if you hit 4 and then 27, if you weren't sure that 27 was a perfect cube, you could check it quick by doing that. So it is a perfect cube because we get 3, a whole number, no decimal part to it, right? So when we factor these, we make a binomial, 2 terms, and a trinomial, 3 terms. Okay? And the way we did the binomial part is we took the cube root of both of these. And the cube root of x cubed will be x. Remember, x to any multiple of 3 power is a perfect cube, to the 3rd or to the 6th or to the 9th power, etc. Okay? So the cube root of x cubed was x. Whatever symbols between them goes between these two. And the cube root of 27 we just saw was what? 3. Thank you. Anybody remember what the trinomial part, how we got that? What do we do with that? Square. Good. That goes first. Since this is minus, what symbol goes next? Plus. Opposite. Good. How do I get this middle term? Multiply these together. Right. What's x times 3? 3x. What do we always say about the 3rd term? It was always plus. And how did we get it?
3 times 3?
Yeah, we squared that 2nd term from here, from the binomial. So we squared the x to get the x squared. We multiplied them together to get the 3x. And then we squared the 3 to get the last term, 3 times 3. Again, the third term was always plus, and this middle term was always opposite of what was in our binomial there. You guys remember that? I haven't done one of those for a while. Okay, so this won't factor anymore. Okay, so I just set them equal to 0, to finish up. This one I'm just going to add 3. So one of my answers is 3. How am I going to get this one if it won't factor? Think about our quiz from Friday. No.
Like what add multiplies.
No. What was
Are you gonna do b divided by 2 squared to find the space for it?
we could do that. We could do the completing the square if you want.
Maybe quadratic.
Quadratic formula. I think I would use quadratic formula. But it's a quadratic, right? It's got an x squared. Those are the type we did last week, right? I would do the quadratic formula, but you could do what Owen said and do the complete the square part if you want, plus blank. But I think you guys are best at using the quadratic formula. So that's what I would do. Let's go x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. I would use the quadratic formula when you have one of these. So if you have a sum or difference of cubes, all right, factor it out like you know how to do. The binomial part's really easy, set it equal to 0. The trinomial part is a quadratic, set it equal to 0 and use your quadratic formula to get your other 2 answers. So we get x equals negative 3 over 2 plus or minus, and let's figure out what that is. Thanks, Allie. So 3 squared is 9. Negative 4 times 1 is negative 4. Times 9 is negative 36. So that's a negative 27, right? Now, we're going to do a little factor tree. So what can I pull out to simplify this? What else? 3i, right? You guys with me on that? What's left underneath? The 3. So there's my other 2 answers. Okay? One answer is 3, the other 2, one of them is negative 3 plus 3i radical 3 over 2, and then the third one is negative 3 minus 3i radical 3 over 2. Now, if they had a number that went into all, if that was a 3 again, or a 6, or a 9 or something, we could divide 3 into all those, right? But since it's a 2, we're done. So that's how you do the sum or difference of cubes. Okay? Factor it like you know how. Cube root both to get the binomial. Write your trinomial part and then set both equal to 0. The trinomial part's a quadratic. Use your quadratic formula. All right, so lots of factoring on today's assignment. Only 5 problems though. Any questions? So 2 to 10 even on page 126. Only 5 problems. So to get a 5 for your homework, do all 5 of them. And you got time, you should probably get it done.